Hi students, today I am going to discuss the concept of advanced encryption standard. So AES is the one of the most popular and widely adopted symmetric encryption algorithm because it is more secured than the data encryption standard or the physical cipher or advanced that is simplified data encryption standard. So basically, it is found to at least 6 times faster than the triple DES. Actually, not only the DES data encryption standard, you can observe in the triple DES. So it is this advanced encryption standard algorithm is 6 times faster than the triple DES. So the replacement for DES was needed to as its key size. So what the problem in the DES is nothing but the key size. So here increasing when the key size is increased, it increases the computing power. So that means it was considered against the attacks which is made by the opponent. So triple DES was designed to overcome this drawback, but it was found slow. So actually whatever the attack is made by the attacker, so the attacker takes some of the techniques. So those are overcome with the help of the triple DES. Actually the triple DES is purely implemented for the sake of that particular concept. But here we can observe what the triple DES, it is very slower. So because of compared to the AES, some of the features can be implemented by AES which are not done by the triple DES. Now you may be observed some of the features of AES is symmetric block cipher. So that means the symmetric key in the sense we know that the single key is operated, but whereas that key can be derived as so many alternatives. So that is the key, and also it should be taken in the symmetric block. And the next one is the 128 bit. So the key size of the bit is the more. So compared to the DES, compared to the triple DES. So here the AES can provided the more key size. And third one is the stronger and faster than the triple DES. So why we can go for the advanced encryption standard AES is nothing but, so it is very stronger and faster than the triple DES. And fourth one is the provide full specification and design details. So in triple DES we have to observe it will not provide all the specifications. So whatever the design process is there, but the AES should be defined. So whatever the specifications are taken, it can be defined the full specification. And the last one is the software implementable in C and Java. It is possible. So that means AES is implemented easily in C programming and Java programming, whereas the triple DES is not possible to handle that much of a capacity. So these are the features of the AES. So what is an operations of AES? Compared to the triple DES, compared to the DES, so the operation is entirely completely different, and it is also based on the substitution permutation network. So here we know that the substitution is a technique. So each element in the plain text is mapping to the other element, and which is also the permutation network. A permutation is taken in the information can be taken in the different order. That means we can't change the element, but we can change the order of the element. So it comprises of a series of linked operation. So the AES contains some linked operation. Linked operation in the sense we observed in the one of the concept. So whatever the input of the second block is depends on the first block output. So sequential logic circuit that we call as a sequential. So it is also a linking process to take the operations one by one. So it involves a specific substitution technique and a specific permutation technique. So the AES includes the both substitution and the permutation can be applied. And one of that AES performs all the computations on bytes rather than the bits. So that means the key size is taken not only in the bit format, so the AES will be considered in the byte format can be defined. Not only that, AES treat as the 128 bit of bits of a plain text block as 16 bytes. So that means we can divide it into the 8 blocks each block contains the 16 bytes. So that means we have to be observed here. So the strength of that particular AES is the more compared to the triple DS and the DS. So the number of rounds in AES is a variable and it depends on the length of the key. So basically in the previous triple DS or the DS, there is a fixed length of the keys taken, and the number of keys or number of rounds are depends on that particular. But here the number of rounds are variable, variable in the sense not the fixed one. So that can be decided based on the input length of the key. So whatever the input length of the key is taken, so based on that we have to take that particular a number of rounds. So AES uses 10 rounds for 20. Here is the sum of the that's why I call the variable length. The variable length of the different rounds are nothing but, so if it is a 128 bit, AES provides the 10 rounds. If it is 192 bits, AES provides the 12 rounds. So if it is a 256 byte data, bit keys data, then it can be considered the 14 rounds. So based on the key size, so the rounds are taken. So for 128 bits, so the 10 rounds are taken. For 192 bit key, so the 12 rounds are taken. For 256 bit, the 14 rounds are taken. So here you can observe compared to the triple DS. So the triple DS is not considered the combinations of the substitution and the permutation, but here it will be defined the both combinations. Not only that, the length of that particular key, not only in the bit format, it may be considered in the byte format, and the key size of the depends on the number of rounds or depends on the key size. Sometimes we can take the 120. There is no fixed or standard key size of AES. So it depends on the key length of the key. So we can decide the number of rounds. So each of the rounds uses a different 128 bit round key, so which is calculated from the original AES key. So whatever the 28 bit different key of data is taken, so the calculation of that particular AES key is the different. Now we go through the structure of this particular one. Here you can observe. So if it is a 10 bit, then you can consider the 128 bit. If it is a 12 bits, it is considered to the 192 bit. If it is a 14 bit, it may be considered to the 256 bit. So now you have to consider this particular is the initial diagram of the AES. So what the AES is the key, here the key expression is nothing but the length of the key. The length of the key is taken. So here the K1, K0, K1, K2 and so on, K, N or number of rounds we have to be based on the number of rounds, the number of keys are generated. If it is 16 rounds, the 16 keys are generated. If the 12 rounds, the 12 keys are generated. Like that, the number of keys can be taken in this particular format. Now you can observe, so this is the round key, 128 bit. So K0 128 bit, K1 28 bit, K2 128 and KR, that is the number of rounds we have to be considered. The number of 128 bits are taken. So each and every key should be taken in the transformation of the data when it can be encrypted. So the plain text is encrypted with the help of the key itself, like that. So the 128 bit plain text is applied to the pre-round transformation. When the pre-round transformation is taken the plain text and applied to the round 1 function. Now you can observe what exactly the round 1 function and round 2 function, round 3 function and so on. So here the number of rounds here based on the key size, already we discussed that. So here a pre-round is taken, the pre-round transformation is taken the 128 bit plain text. So that may be the encrypted with the help of the particular process that can be derived the round 1. Now the round 1 data is applied to the round 2, round 2 data is applied to the, so and so on the round NR. So it is a number of rounds has to be considered. Each and every round can be substituted the key K0, K1, K2 and so on, KR, that is the number of rounds. So this is the actual process of this particular AES, and also you can observe the relationship between the number of rounds and cipher key size. So the cipher key size is nothing but based on the key size, the number of rounds can be taken. Now you can observe this particular diagram. So what the encryption process of? here the four important factors should be defined. So the first that means the 4 rounds are considered. The first round, how we can be encrypted, the second round how we can encrypt the third round and fourth round. If it is on 5, it is on 6, it is on 7, the number of round process can be repeated in the similar way. So that means here you can consider. So the description of this particular AES is nothing but here you have to take the plain text and apply to the add round key, and the next one. So here whatever the round function is the combination of the 4 factors. One is the SubBytes, and second one is the shift rows, and the third one is the mix columns, and the last one is the add round key. So these are the 4 important factors functions under the process of the AES. Now we go for the detailed discussion of this particular encryption process. Now you can observe here in the ciphertext. So the key size of this is nothing but the 128 bits. So 128 bit key is applied to this particular round function of the add round key. Now we can observe in the detailed discussion of the encryption process. Now here what is the first one? SubBytes. So there are 4 important functions are there in this particular round function. So SubBytes is there. So next one is the shift rows and the mix column and the add round key. So what exactly the SubBytes? A SubByte is nothing but the 16 input bytes are substituted by looking up a fixed table. So that means X boxes. Fixed table is nothing but the substitution boxes. So the 16 input bytes are taken from the substitution boxes. So that is the SubBytes, substitution bytes. So whatever the S boxes are designed, so the result of the matrix is the 4 rows or the 4 columns. That means how many input bytes are there? 4 into 4 is nothing but the 16. So that means 16 input bytes are taken with the 4 rows and the 4 columns. So this is the first function of the SubBytes. And second one is the shift rows. What the shift rows is nothing but each of the 4 rows of the matrix is shifted to the left. So that means whatever the matrix we have to be defined in the 4 rows, that will be shifted to the right one and shifted to the left one. So that means here we can consider the carry of the element, the main focus on the left side. So any entities that fail off, so the reinserted of the right side of row. So that means if any failure occurred in the process, again we can refill the process in the right side and it can be moved into the left one. So this is a shift rows. Shift rows in the sense, suppose the last way. So for example, so I will show it how it can be shifted. Suppose the data should be 10010. Suppose if the shift left bit in the sense 1, so left shift by 1 in the sense 0010, 0010 and 0010 and 1. So that means this left one is converted into this particular right one. So here data 0010 and 1. So this is the shifted data. That means the rows can be shifted from one place to another place. Here maximum it can be moved into the left side. So here some of the shift operations should be taken. The first one, the first row is not shifted. So the first row is doesn't consider the first row because it is not shifted. The second row is shifted one position to the left. So if you move the second bit, it can be taken only the one position at a time. So suppose the third row is shifted two positions to be the left hand, and the fourth row is shifted 3 positions to be left hand. So the resulting new matrix consisting of the 16 bits of the shifted. So here similarly, so in the first row not shifted. So similarly we have to take that one. If you consider the second row, so you have to be shifted to one position to the left, and in the third row you have to shift the 2 positions to the left, and if you consider the fourth row, you have to shift the 3 positions to the left. So this is a main concept of this particular shift rows. And third one is the mix column. What exactly the mix column is nothing but each column of the 4 bytes is now transferred using a special mathematical function. Here we can use some of these special mathematical function. That mathematical function can be derived a sum of the 16 rounds data, and the last one is the add round key. Add round key is nothing but here we can use the XOR operation. XOR operation should be considered between the mix column that means round 1 to the round 2, and in that round 1 function, so add sub keys are nothing but we can add one by one key with the help of the exclusive OR operation. So this is what exactly in the AES process. The decryption is the reverse of the encryption process. That's why it will be started from the reverse order: add round key, mix column, shift rows, and the byte substitution. So in the previous, the encryption started with the byte substitution, shift rows, and mix column, and add round key. This is the process of the AES. Thank you.